So I wanted to talk a little bit about systems of equations. Systems of equations is where you have a set of two or more equations considered at the same time. So you can think of this as having a graph and having maybe two lines on that same graph. The solution to this system, this would be an example of a system. The solution to this system would be where those two graphs intersect. So I wanted to show you, you have three different cases of this, and I just wanted to show you some general information about those three cases before I work any problems, okay? So this is going to be the ordered pair, which makes both equations true at the same time. This is where they intersect, if they intersect. Some don't. So if we look at this first equation that we have here, our slope is 2, and our y-intercept is, remember this is b, so our y-intercept is 0, 1, 0b. Okay? Slope is 2, that's rise over run, so rise would be 2, so we're going up 2. Run would be 1. So that's going to make us go right 1. So let's graph that line. I know it's already on here. I just want you to see what happens here. So, and if these were not on here, how you would work through that. Okay, so if I start with my y-intercept of 0, 1, and I'm going to go up 2 from that point and then right 1. So from this point, the y-intercept, I'm going to go up 2, right 1. And I could continue doing that, up 2, right 1. Okay, I could also go down 2, left 1. Okay, and that's where you get this line here. So that would be this first graph. The second graph has the y-intercept of 0, 7, and the slope is negative, and remember there's a 1 there, so a negative 1. And this is tricky because with the negative, you do want to make this a fraction, but you need to think about that negative is not, can't go both on top and on bottom. It can only go one of those places. So you need to choose. If I put it on top, then instead of going up, I'm going to go down and to the right. If I put it on bottom, I'm going to go up and to the left instead of going right. Here, I'm going to leave it on top as it is, and so I'm going to go down 1, right 1. Okay, so let's do that with this one. So I've got 0, 7, 0, 7, and here I'm going down 1, right 2. I'm sorry, down 1, right 1. So down 1, right 1. Down 1, right 1. Down 1, right 1. Okay, and that's why we're making this graph. So the answer is not the graph. The answer is where these two lines cross, where they meet, where they intersect. So the intersection of these two points, these two lines is the point 2, 5. And as a note, if I take this 2 and 5 and I plug it in here, this would be 2 times 2 plus 1, that's 5, and that does equal the y value of 5. If I plug that in here, negative 5 plus 7 is 2. I'm sorry, negative 2 plus 7 is 5, because our x value is 2. Negative 2 plus 7 is 5, and that does equal 5. So do you see that both of these are true when it is this point 2, 5? Okay, so this is when it does actually intersect. This system is consistent and independent. It has an answer, and the two graphs are not the same. The two lines are not the same. They're not dependent on each other. Okay? So that's one option, one type of solution. Okay? If we look at the second one, the lines are the exact same line. So I want you to see real quick, if I was to solve this for y, I would have y equals, add 2x plus 1. Here, let me do some work here. Okay, solve this one for y. So if you're not sure, solve both of them for y and let's see what happens. Okay, so here we're going to move this over. Add 4x, that's going to give me 2y equals 4x plus 2. Divide by 2 all the way across. So I get y equals 2x plus 1. Do you see this line is the same as this one? So there's no need in me graphing both of these. It's going to be this one line. So these two do have an answer. And basically everywhere on that line is the same. So it's going to, everywhere on that line is going to make the system true. So therefore there is an infinite number of solutions. There's an infinite number of places where these two lines intersect because they are the same line. They lie on top of each other. Okay, so this system does have a solution. There's just infinitely many of them. But because it's the same line, it's a dependent system. So again, this is consistent and dependent. So let's look at our last case. The last case is if these two lines are parallel. So let's graph these again. I've got the y-intercept of 1, 0, 1. Rise 2, right 1. Okay, so this is 2 over 1 for the slope. So I'm going to rise 2, right 1, rise 2, right 1. So I end up getting this line. And then this one is y-intercept 5, 0, 5. Slope, rise 2, right 1. I could also go down 2, left 1. I would get this line. Okay? So these you can tell are parallel. You can also tell another way based off of previous information we've done. Notice that the slope is the same. And remember, if the slope is the same, then that means that those two lines are parallel. Okay, and you can see that because the y-intercepts are different, then that's not going to be the exact same line, but because they have the same slope, they will be separated, so they're parallel. Notice that these do not cross and they will never cross, so there will be no intersection, so there is no solution to this system. It is inconsistent because there is no solution, and it is still independent though because the lines are not the same line. So they're independent of each other. Okay? So that would be your answer here. It would be no solution because these do not intersect. The system is inconsistent and independent. So that gives you the three options for looking at systems of equations graphically.